when vehicle moves on a curved banked road, the required safe speed V is equal to under root Rg tan of theta. Well, theta is angle of banking. So, if we determine certain velocity v with which the car should pass through this curved banked road, if we decide the velocity with which it has to pass, then in the construction of the road, we'll have to bind the road with certain angle of banking. So we can find this angle of banking as we know this particular expression, V square is equal to Rg tan theta. Therefore, tan theta is equal to V square upon Rg. Therefore, the required angle of banking theta can be expressed as tan inverse of V square upon Rg. And so here we see that theta depends upon V, R and G. So as the value of theta increases, the value of V with which the vehicle can be moved. So we have seen this particular example as in case of the cycle racing in the stadium. We have seen the construction of a velodrome. So for a horizontal track, the edge then thereafter is banked in this way. So as the speed of the cyclist increases, he enters into this particular zone where his inclination goes on increasing so that he can meet the requirement of the safe speed. And so, velodrome is a good example where we can see the safe speed can be achieved. When the motorcyclist rides his motorcycle on curved horizontal road, usually he leans. When he gets tilted with respect to the normal, he forms an angle theta with normal, so that as the angle increases, the safe speed requirement also increases, and so he can safely take a turn with higher velocities. We have seen that in some amusement parks or in our village fair, we have seen one amusement event which is called as Well of Death. Maut ka Kuwa. In this case, a motorcyclist rides his motorbike on this vertical wall. So when he rides his motorcycle, the forces act on him, the weight will be acting in vertically downward direction, mg. Normal reaction will be normal to the vertical wall, and so it will be directed inward. This is the normal reaction. As he moves on the circular track, centrifugal force mv square upon r, where r is the radius of this circular track. In its case, the frictional force acts in the upper direction. Frictional force acts in the upper direction. So if we resolve all these forces in equilibrium condition, here we see that the weight mg, if is more than frictional force, then this motorcycle is going to fall down, because the weight of this particular system is more than the frictional force. So this frictional force should be equal to mg in minimum, or it should always be greater than mg. So frictional force should be greater than mg. In equilibrium condition, we will consider this frictional force is equal to mg. Normal reaction N, this is equal to mv square upon r, where v is the required velocity with which he should take the circular turns. By definition, we know the frictional force is directly proportional to normal reaction. So frictional force will be equal to mu times n. Mu is the coefficient of friction.